What if the next great leap in humanity's journey wasn't just about exploring Mars, but about bringing a piece of Earth with us? Picture this, a sprawling, futuristic zoo on the red planet, where lions prowl under a pink sky and elephants roam across alien soil. But here's the twist. How would we care for these animals in an environment that's completely foreign to them? This isn't just a sci-fi fantasy. It's a question that ties directly into the future of space exploration and biotechnology. As we push the boundaries of what's possible, creating a Mars zoo could become a symbol of our ability to adapt and thrive in the most extreme conditions. In this video, we'll dive into the challenges and innovations required to make this vision a reality, from designing habitats that mimic Earth's ecosystems to developing cutting-edge life support systems. It's not just about the animals, it's about what this endeavor says about us as a species. So let's explore what it would take to build and maintain a zoo on Mars, and why this idea might be closer to reality than you think. Imagine stepping into a massive, transparent biodome on Mars, where the air is thick with the scent of Earth's soil and the sound of birdsong echoes through the air. Outside, the Martian landscape stretches endlessly red, barren, and alien. But inside, life thrives. Lions lounge under artificial sunlight, monkeys swing through trees grown in Martian soil, and schools of fish dart through crystal-clear water. This isn't just a zoo, it's a living, breathing piece of Earth transported to another world. But why would we go to such lengths to create a Mars zoo? The answer lies in two powerful motivations: preservation and inspiration. On one hand, a Mars zoo could serve as a safeguard for Earth's biodiversity, protecting endangered species from the growing threats of climate change and habitat destruction. On the other hand, it could inspire humanity to dream bigger, showing us that life can flourish even in the harshest environments. But here's the catch: Mars isn't Earth. The gravity is weaker, the atmosphere is thin, and the temperatures are extreme. How do we adapt Earth's animals to these conditions? Could we genetically modify them to thrive in lower gravity? Or would we need to create artificial ecosystems that mimic Earth's environment down to the smallest detail? These questions aren't just hypothetical, they're the foundation of a vision that could redefine our relationship with the cosmos. And to make this vision a reality, we'll need to push the boundaries of technology, from advanced life support systems to revolutionary genetic engineering. The journey to creating a Mars zoo isn't just about the animals, it's about proving that humanity can overcome the impossible. So, what would it take to turn this dream into reality? Let's dive into the challenges and the breakthroughs that could make a Mars zoo not just possible but inevitable. So, how do you recreate Earth's lush forests, sprawling savannas, and vibrant coral reefs on a planet where the air is barely breathable and the ground is frozen solid? Designing habitats for a Mars zoo isn't just about building walls and roofs, it's about engineering entire ecosystems from scratch, the first challenge. Mars' thin atmosphere, which is about 1% as dense as Earth's. Without proper protection, the animals would be exposed to deadly radiation and freezing temperatures that can drop to -80 degrees Celsius. The solution: pressurized domes made from advanced materials like graphene or aerogels, which are lightweight yet incredibly strong. These domes would act as giant, airtight bubbles, shielding the animals from the harsh Martian environment while maintaining the right pressure and temperature inside. But it's not just about keeping the bad stuff out, it's about bringing the good stuff in. Climate control systems would need to replicate Earth's seasons, humidity, and even the subtle changes in air pressure that animals are used to. Imagine a rainforest habitat where the air feels thick and humid, or a desert enclosure where the heat radiates just like it would on Earth. every detail matters because even small changes can stress animals and disrupt their natural behaviors. But here's where it gets even more complex. Animals don't just need air and warmth, they need ecosystems. A lion isn't just a lion, it's part of a delicate web of life that includes the grass it walks on, the insects that pollinate the plants, and the microbes in the soil. Replicating these ecosystems on Mars would require a level of precision that's never been attempted before. We'd need to create artificial soils rich in nutrients, grow plants that can thrive under Martian light, and even introduce Earth's microorganisms to maintain the balance of life. And let's not forget water, a precious resource on Mars. Advanced recycling systems would be essential to ensure that every drop is reused, from the water that animals drink to the moisture in the air. It's a monumental task, but one that could teach us invaluable lessons about sustainability and resilience. Now, here's the big question. Even if we can build these habitats, how would the animals adapt to living in them? Would a giraffe feel at home under an artificial sky? Or would a penguin recognize a frozen Martian lake as its natural habitat? These aren't just philosophical questions, they're critical to the success of a Mars zoo. Animals are incredibly sensitive to their environments, and even the most advanced technology can't fully replicate the subtle cues they rely on. Would we need to genetically modify some species to help them adapt, or could we train them to thrive in these new conditions? The answers to these questions could shape not just the future of a Mars zoo, but the future of life beyond Earth. And as we push the boundaries of what's possible, we might just discover that the key to survival on Mars lies in understanding the delicate balance of life on Earth. Now, let's tackle one of the most fascinating and challenging aspects of a Mars zoo. How do we adapt Earth's animals to a world that's so fundamentally different from their own? Transporting animals to Mars isn't just about building a spaceship big enough for elephants or giraffes. It's about ensuring they can survive and thrive in an environment with weaker gravity, less oxygen, and constant exposure to radiation. These aren't just logistical hurdles, they're biological ones. For example, Mars has only about 38% of Earth's gravity. What would that do to an animal's muscles, bones, and even its circulatory system? On Earth, gravity helps shape how animals grow and move. A lion's powerful legs are built to sprint across savannas, and a bird's wings are designed to soar through dense air. But on Mars, everything changes. Would a lion's muscles atrophy in lower gravity, or would a bird struggle to fly in thinner air? These are the kinds of questions scientists would need to answer before bringing animals to the Red Planet. One potential solution lies in genetic engineering. By tweaking an animal's DNA, we could potentially create versions better suited to Martian conditions. Imagine a giraffe with denser bones to counteract the effects of lower gravity, or a penguin with a more efficient respiratory system to handle Mars' thin atmosphere. Genetic engineering could even help animals tolerate higher levels of radiation, a constant threat on Mars. But this raises another question: how far is too far? At what point does modifying an animal's biology cross the line from adaptation to creating something entirely new? And what about the ethical implications? Would it be fair to alter an animal's fundamental nature just to suit our ambitions? These are questions that don't have easy answers, but they're essential to consider as we explore the possibilities of a Mars zoo. Another approach could be selective breeding. Instead of directly modifying genes, we could breed animals over generations to favor traits that make them better suited to Mars. This method has been used for centuries on Earth. Think of how dogs have been bred for specific roles, from herding sheep to guarding homes. But selective breeding takes time, and time is a luxury we might not have if we're racing to establish a presence on Mars. Plus, there's no guarantee that the traits we want would emerge naturally, or that the animals would remain healthy and viable over the long term. Then there's the idea of creating hybrid species animals that combine traits from Earth species with those from extremophiles, organisms that thrive in Earth's harshest environments. For example, could we combine the resilience of a tardigrade, which can survive in the vacuum of space, with the biology of a mammal? While this might sound like science fiction, it's a concept that's already being explored in labs around the world. But again, this raises ethical questions. Would these hybrids still be considered Earth animals, or would they become something entirely new? And how would we ensure their welfare in an environment as unforgiving as Mars? Of course, even with these adaptations, animals would still need constant monitoring and support. This is where technology comes in. Advanced sensors and artificial intelligence could track everything from an animal's heart rate to its stress levels, ensuring that any issues are caught and addressed immediately. Robotic caretakers could assist with feeding, cleaning, and even medical care, reducing the need for human intervention in an environment where every resource is precious. And let's not forget, virtual reality scientists could use VR to simulate Earth-like conditions, helping animals acclimate to their new surroundings without unnecessary stress. But here's the thing, no matter how advanced our technology becomes, the welfare of these animals must always come first. A Mars zoo wouldn't just be a scientific achievement, it would be a moral responsibility. Every decision, from the habitats we design to the adaptations we pursue, would need to prioritize the well-being of the animals. After all, if we're going to bring a piece of Earth to Mars, we owe it to these creatures to make sure they can live healthy, fulfilling lives. And as we navigate these challenges, we might just discover that the key to thriving on Mars lies not in conquering the environment, but in learning to coexist with it, just as we've done on Earth. So, what role will technology play in this delicate balance? Let's explore that next. Now, let's talk about the backbone of any Mars zoo, the life support systems that would keep both animals and caretakers alive in an environment where even the air is trying to kill you. On Mars, every breath, every drop of water, and every scrap of waste would need to be meticulously managed. This isn't just about survival, it's about creating a self-sustaining oasis in the middle of a barren, hostile world. So, how do we generate oxygen, recycle water, and manage waste on a planet where none of these resources exist naturally? The answer lies in cutting-edge technology that's already being tested here on Earth. First, let's tackle oxygen. Mars' atmosphere is 95% carbon dioxide, with almost no oxygen to breathe. To solve this, we'd need advanced oxygen generation systems, like the ones being developed for future Mars missions. One promising technology is MOXIE, an instrument currently on NASA Perseverance rover, which converts carbon dioxide into oxygen through a process called electrolysis. In a Mars zoo, scaled-up versions of this technology could provide a steady supply of breathable air for both animals and humans. But here's the catch, oxygen isn't just for breathing. It's also essential for maintaining the right balance in the zoo's ecosystems. Plants, for example, need oxygen at night, while animals need it around the clock. Balancing these demands would require precise control, likely managed by AI-driven systems that monitor and adjust oxygen levels in real time. Next up, water. On Mars, water is scarce, and every drop would need to be recycled with near-perfect efficiency. Advanced filtration systems, similar to those used on the International Space Station, could purify wastewater from animal enclosures, human habitats, and even the air itself. But a Mars zoo would need to go even further. Imagine a closed-loop water system where every molecule is reused: rainwater collected from the domes, moisture extracted from the air, and even the water content in animal waste recycled into clean, drinkable water. It's a level of sustainability that could revolutionize how we think about resource management, not just on Mars but here on Earth as well. Then there's waste management. On Earth, waste is often out of sight, out of mind, but on Mars there's no such luxury. Every scrap of organic waste, from animal droppings to uneaten food, would need to be processed and repurposed. One solution: composting systems that turn waste into nutrient-rich soil for the zoo's plants. Another option is bioreactors, which use microorganisms to break down waste and produce useful byproducts like methane, which could be used as fuel. These systems wouldn't just keep the zoo clean, they'd also play a crucial role in maintaining the delicate balance of its ecosystems. But here's where it gets even more fascinating. All of these systems would need to work together seamlessly, and that's where AI comes in. Imagine a network of sensors and algorithms constantly monitoring oxygen levels, water quality, and waste processing, making adjustments in real time to ensure everything runs smoothly. AI could predict potential issues before they become problems, like a drop in oxygen levels or a spike in water contamination. It could even optimize resource use, ensuring that nothing goes to waste in an environment where every resource is precious. And let's not forget the role of robotics. Maintaining these life support systems would be a massive task, and human caretakers can't be everywhere at once. That's where robotic assistants come in. Picture small, autonomous robots patrolling the zoo, checking equipment, cleaning enclosures, and even performing minor repairs. These robots wouldn't just save time and labor, they'd also reduce the risk of human error in an environment where even a small mistake could have catastrophic consequences. So, what does all of this mean for the future of life on Mars? It's not just about keeping animals alive, it's about creating a blueprint for sustainable living in the most extreme conditions. The technologies developed for a Mars zoo could have far-reaching implications, from improving resource management on Earth to enabling long-term human settlements on other planets. And as we push the boundaries of what's possible, we might just discover that the key to thriving on Mars lies in learning to work with the environment rather than against it. But how do we ensure these systems are reliable enough to support life for years or even decades? That's where the next piece of the puzzle comes in: robotics and automation. Now, let's shift our focus to one of the most exciting aspects of a Mars zoo: the role of robotics and automation in animal care. Imagine a world where robots are the primary caretakers, ensuring that every animal is fed, healthy, and thriving, all while humans oversee operations from a distance. This isn't just about convenience, it's about creating a system that's efficient, precise, and capable of handling the unique challenges of life on Mars. So, how could robots and AI transform the way we care for animals in this futuristic environment? Let's dive in. First, consider the basics: feeding. On Earth, zookeepers spend hours preparing meals, distributing them, and monitoring how much each animal eats. But on Mars, where resources are limited and every task must be optimized, automated feeding systems could take over. Picture robotic arms equipped with sensors, carefully measuring out portions and delivering them to each enclosure at the perfect time. These systems wouldn't just save time, they'd also ensure that every animal gets the exact nutrients it needs, tailored to its species, age, and health. And with AI tracking consumption patterns, any changes in appetite could be flagged immediately, alerting caretakers to potential health issues before they become serious. But feeding is just the beginning. Monitoring animal health in a Mars zoo would require constant vigilance, and that's where drones come in. Imagine small, nimble drones equipped with cameras and sensors, flying through the biodomes to check on animals without disturbing them. These drones could monitor everything from body temperature to heart rate, using AI to analyze the data in real time. If a lion seems lethargic or a bird's feathers look dull, the system could alert human caretakers or even robotic veterinarians to investigate further. This level of precision would be impossible for humans to achieve alone, especially in an environment as vast and complex as a Mars zoo. Speaking of robotic veterinarians, this is where things get truly futuristic. Picture a robot capable of performing routine checkups, administering medications, and even assisting with minor surgeries. These robotic vets could be equipped with advanced imaging tools like X-ray and ultrasound, allowing them to diagnose issues without the need for invasive procedures. And because they're powered by AI, they could continuously learn and improve, becoming more effective over time. Of course, human oversight would still be essential, but the ability to delegate routine tasks to robots would free up human caretakers to focus on more complex challenges. Then there's the question of animal behavior. On Earth, zookeepers rely on years of experience to understand the subtle cues that indicate an animal's mood or health. But on Mars, where every detail matters, AI could take this to the next level. Imagine a system that uses cameras and sensors to track an animal's movements, vocalizations, and interactions with its environment. Over time, the AI could build a detailed profile of what normal looks like for each individual, flagging any deviations that might signal stress, illness, or other issues. This kind of behavioral analysis could revolutionize how we care for animals, ensuring that their physical and emotional needs are met in a way that's never been possible before. But here's the thing, while robots and AI could handle many tasks, the human element would still be crucial. After all, a Mars zoo wouldn't just be a scientific endeavor, it would be a testament to humanity's ability to care for other living beings, even in the most extreme conditions. Human caretakers would play a vital role in overseeing operations, making ethical decisions, and providing the empathy and intuition that machines can't replicate. They'd be the ones ensuring that the zoo's mission to protect and inspire remains at the heart of everything we do. So, what does this mean for the future of animal care on Mars? It's not just about replacing humans with robots, it's about creating a partnership between technology and humanity, where each complements the other's strengths. By leveraging robotics and AI, we could create a system that's not only efficient and precise, but also deeply attuned to the needs of the animals in our care. And as we push the boundaries of what's possible, we might just discover that the key to thriving on Mars lies in finding the perfect balance between innovation and compassion. But how do we ensure that this balance is maintained over the long term? That's where the human element comes into play, and it's a topic we'll explore next. Now, let's talk about the unsung heroes of a Mars zoo, the human caretakers. These aren't just zookeepers, they're pioneers, scientists, and problem solvers tasked with maintaining life in one of the most extreme environments imaginable. But what would it really be like to work in a Mars zoo? Imagine being millions of miles from Earth, surrounded by a barren, alien landscape, with the weight of an entire ecosystem resting on your shoulders. The challenges are immense, not just physically, but mentally and emotionally. Isolation, confinement, and the constant pressure to keep everything running smoothly would test even the most resilient individuals. So, what kind of person would thrive in this role, and what would it take to prepare them for such a monumental task? First, let's talk about the skills. A Mars zookeeper wouldn't just need to understand animal behavior, they'd need to be a jack of all trades. Expertise in biology would be essential, of course, but so would a deep understanding of engineering, robotics, and even space travel. After all, maintaining life support systems, repairing equipment, and troubleshooting technical issues would all be part of the job. Picture someone who's as comfortable with a wrench as they are with a stethoscope, able to diagnose a sick animal one moment and fix a malfunctioning oxygen generator the next. This isn't just a job, it's a calling requiring a unique blend of knowledge, adaptability, and creativity. But it's not just about technical skills. Working in a Mars zoo would also demand incredible emotional resilience. Imagine spending months or even years away from Earth with only a small team for company. The isolation could be overwhelming, and the psychological toll of living in such a confined, high-pressure environment would be significant. Caretakers would need to be mentally prepared for the challenges of space travel, from the disorientation of lower gravity to the constant awareness that help is millions of miles away. Training programs would likely include simulations of Martian conditions, as well as psychological support to help caretakers cope with the unique stresses of their role. And then there's the importance of teamwork. In an environment where every decision could mean the difference between life and death, collaboration would be key. Caretakers would need to work closely with engineers, biologists, and even AI systems to ensure that the zoo runs smoothly. Communication would need to be clear and precise, with everyone on the same page at all times. Picture a team of specialists, each bringing their own expertise to the table, working together to solve problems and innovate on the fly. It's this spirit of teamwork and shared purpose that would make a Mars zoo not just possible but successful. But here's the question that lingers. What are the ethical implications of this endeavor? Bringing animals to Mars isn't just a technical challenge, it's a moral one. Are we right to take these creatures from their natural habitats and place them in an environment that's completely alien to them? What responsibilities do we have to ensure their well-being, not just physically but emotionally? These are questions that don't have easy answers, but they're essential to consider as we push the boundaries of what's possible. A Mars zoo wouldn't just be a scientific achievement, it would be a reflection of our values as a species. And as we navigate these challenges, we might just discover that the key to thriving on Mars lies not just in our technology, but in our humanity. So, what does the future hold for this bold vision? Let's explore that next. Now, let's tackle one of the most complex and thought-provoking aspects of a Mars zoo, the ethical considerations. Imagine this: you're standing in a biodome on Mars, watching a lion roam across a simulated savanna. It's a breathtaking sight, but it also raises a profound question. Is this right? Are we justified in bringing Earth's animals to a world that's so fundamentally different from their own? This isn't just a question of logistics or technology, it's a question of morality. And as we push the boundaries of what's possible, we need to ask ourselves, where do we draw the line between scientific progress and ethical responsibility? Let's start with the animals themselves. Transporting creatures to Mars would be an enormous undertaking, and the journey alone could be incredibly stressful. Imagine a giraffe confined to a spacecraft for months, enduring the vibrations of launch, the weightlessness of space, and the uncertainty of landing on an alien world. Even if we could ensure their physical safety, what about their mental well-being? Animals are deeply connected to their environments, and the sudden shift to a completely foreign habitat could cause confusion, stress, or even trauma. Would it be fair to subject them to this kind of upheaval, even if our intentions are noble? These are questions that don't have easy answers, but they're essential to consider as we explore the possibilities of a Mars zoo. Then there's the issue of Martian ecosystems, or the lack thereof. Mars is a barren, lifeless planet, but that doesn't mean it's devoid of value. Some scientists argue that introducing Earth's organisms to Mars could disrupt any potential native life forms, no matter how microscopic. Even if we don't find life on Mars today, contaminating the planet with Earth's microbes could make it harder to study its natural history in the future. And what if we accidentally introduce invasive species that could thrive in Martian conditions, altering the planet's environment in ways we can't predict? The risks are real, and they raise important questions about our responsibility to preserve the integrity of other worlds. But here's the thing, The ethical challenges of a Mars zoo aren't just about the animals or the planet, they're about us. What does it say about humanity if we're willing to take such drastic steps to bring life to another world? On one hand, it's a testament to our ingenuity and our desire to explore. On the other hand, it raises concerns about our tendency to impose our will on the universe, often without fully considering the consequences. Are we playing the role of creators, or are we overstepping our bounds? These are questions that go beyond science and touch on the very essence of what it means to be human. To navigate these ethical dilemmas, we'll need more than just technology, we'll need collaboration. Creating a Mars zoo would require input from scientists, ethicists, policymakers, and even the public. International guidelines would be essential to ensure that the project is conducted responsibly, with clear boundaries and safeguards in place. Imagine a global effort to establish ethical standards for space exploration, ensuring that our actions on Mars reflect the best of humanity, not just our ambitions. This kind of collaboration could set a precedent for how we approach other challenges, from climate change to genetic engineering, showing that progress and responsibility can go hand in hand. And let's not forget the broader implications. A Mars zoo wouldn't just be a scientific achievement. It would be a symbol of our ability to adapt and thrive in the most extreme conditions. But it would also be a reminder of our responsibility to protect and preserve the life we bring with us. As we push the boundaries of what's possible, we need to ask ourselves, what kind of future do we want to create? One where we conquer the cosmos at any cost, or one where we learn to coexist with the universe in a way that's sustainable, ethical, and compassionate? The answers to these questions will shape not just the future of a Mars zoo, but the future of humanity itself. So, as we dream of lions under a pink sky and elephants on alien soil, let's also remember the weight of the choices we make and the legacy we leave behind. Now, let's zoom out and consider the bigger picture. What would a Mars zoo mean for humanity as a whole? This isn't just about creating a tourist attraction on another planet. It's about what this endeavor says about us as a species. Imagine a child on Earth gazing up at the night sky, knowing that somewhere on Mars, lions are prowling and birds are singing. That child isn't just seeing a distant planet. They're seeing a future where humanity has expanded its reach, where the impossible has become possible. A Mars zoo could inspire generations to dream bigger, to push the boundaries of what we think is achievable. It's not just a zoo, it's a symbol of hope, innovation, and our unrelenting drive to explore. But the impact goes beyond inspiration. A Mars zoo could also be a game changer for scientific research. Think about it. Studying how Earth's animals adapt to Martian conditions could unlock new insights into biology, genetics, and even the origins of life itself. What if the key to understanding how life evolves on other planets lies in watching a giraffe walk under a pink sky or a penguin swim in a frozen Martian lake? These observations could revolutionize our understanding of biology, helping us answer questions we haven't even thought to ask yet. And let's not forget the potential for medical breakthroughs. Studying how animals cope with lower gravity or higher radiation could lead to new treatments for humans, both on Earth and in space. A Mars zoo wouldn't just be a place to see animals. It would be a living laboratory, advancing science in ways we can't yet imagine. Then there's the role a Mars zoo could play in space colonization. If we can create a self-sustaining ecosystem on Mars, one that supports a diverse range of life, what's stopping us from doing the same for humans? The technologies developed for a Mars zoo, from advanced life support systems to AI-driven resource management, could pave the way for permanent human settlements on the Red Planet. It's not just about survival, it's about thriving. A Mars zoo could be the first step toward creating a new home for humanity, one where we live in harmony with the environment, just as we've learned to do on Earth. But perhaps the most profound impact of a Mars Zoo would be its role in preserving Earth's biodiversity. As climate change and habitat destruction threaten countless species, a Mars Zoo could serve as a kind of ark, safeguarding endangered animals in a place where they're protected from the dangers of our own planet. It's a sobering thought that we might need to send life to another world to ensure its survival. But it's also a reminder of our responsibility to protect the incredible diversity of life on Earth. A Mars Zoo wouldn't just be a refuge for animals, it would be a testament to our commitment to preserving the natural world, even as we reach for the stars. And let's not overlook the symbolic significance of bringing life to another planet. For centuries, Mars has captured our imagination as a barren, lifeless world. But what if we could change that? What if we could transform Mars from a desolate wasteland into a thriving oasis teeming with life? It would be a powerful statement about humanity's ability to shape the universe, to bring light and life to the darkest corners of existence. A Mars Zoo wouldn't just be a scientific achievement, it would be a declaration of our potential as a species, a reminder that we are capable of incredible things when we work together. Of course, none of this comes without challenges, from the technical hurdles of building habitats to the ethical dilemmas of transporting animals. Creating a Mars Zoo would be one of the most complex projects humanity has ever undertaken. But with every challenge comes an opportunity to innovate, to learn, and to grow. A Mars Zoo isn't just a dream, it's a call to action, a challenge to push the boundaries of what's possible and to create a future where life flourishes, not just on Earth but across the cosmos. So, as we look to the stars and imagine lions under a pink sky, let's also remember the lessons we've learned on Earth. A Mars Zoo wouldn't just be about the animals, it would be about us. It would be a reflection of our ingenuity, our compassion, and our unyielding desire to explore. And as we take those first steps toward making this vision a reality, we might just discover that the key to thriving on Mars lies not in conquering the unknown, but in embracing it with curiosity, humility, and a deep respect for the life we bring with us. So, what have we learned about the incredible possibilities and challenges of a Mars Zoo? From designing pressurized biodomes that mimic Earth's ecosystems to developing cutting-edge life support systems that recycle every drop of water, the technical hurdles are immense. But so are the opportunities. We've explored how genetic engineering and selective breeding could help animals adapt to Mars' unique conditions, and how robotics and AI could revolutionize animal care in ways we've never imagined. We've also grappled with the ethical questions. Is it right to bring Earth's animals to another planet? How do we balance our ambitions with our responsibility to protect and preserve life? These aren't just questions for scientists, they're questions for all of us. At its core, a Mars Zoo isn't just about animals, it's about humanity. It's a testament to our ability to innovate, to adapt, and to dream big. It's about pushing the boundaries of what's possible, not just for ourselves, but for the countless species we share this planet with. And it's a reminder that the future of life, on Earth and beyond, depends on our ability to think creatively, act responsibly, and work together. But here's the big question: are we ready to take this giant leap? Are we prepared to bring a piece of Earth to Mars, not just as a symbol of our ingenuity, but as a promise to protect and inspire? The journey to creating a Mars Zoo is about more than technology or biology. It's about what it means to be human in an ever-expanding universe. And as we stand on the brink of this new frontier, we have to ask ourselves, what kind of future do we want to create? So, what do you think? Is a Mars Zoo a bold step forward or a step too far? Share your thoughts in the comments below. We'd love to hear your perspective. And if you're as fascinated by the possibilities of the future as we are, don't forget to subscribe and hit that notification bell. Together, let's keep exploring the incredible, the impossible, and everything in between. The future is waiting, let's see where it takes us.